Hey everybody, Mr. Quick here. Today we're going to be looking at Eureka Math / Engage New York Math, Module 3, Lesson 13, Statements of Order in the Real World. So obviously when we talk about order, we're talking about putting things in order. When we talk about real world, we're talking about actual application of these math concepts. So let's just jump into a couple of examples here. Okay, example number 1. Again, from Eureka Math. Scientists are studying temperatures and weather patterns in the northern hemisphere. They recorded temperatures in degrees Celsius in the table below, as reported in emails from various participants. Represent each reported temperature using a rational number. Order the rational numbers from least to greatest. Explain why the rational numbers that you chose appropriately represent the given temperatures. So, that's a whole lot of talking, but what we're looking at here is these are the temperatures that they reported. Everything up here is what they actually told the weather service or the scientists that the temperature was. Down here, we're going to be writing the temperature using rational numbers. And there's a few that are kind of filled in for us to give us a little bit of a help or heads up. And then there's even a couple up top that we have to fill in. So let's take a look here. 8 below 0. Well, if the temperature is 8 degrees below 0, then that would be -8, right? Because it's below 0, that would be a negative number on the number line. It's before or below 0 on the number line. 12 degrees Celsius, since that's a positive number, that would just be 12. -4, you got it, it's -4, right? -4 degrees or 4 degrees below 0 are the same thing. They're both -4. 13 degrees below 0, since it's below 0 or before 0 on the number line, we're looking at -13. 0 is just 0. Simple as that, right? Don't overthink it. 0 degrees is 0 degrees. To above 0. Above is our key word there. So instead of being below the 0 on the number line, the 2 would be above it, making it a positive number. And then these last two, we actually have the temperature in Celsius, but we need to figure out how we want to write it. So for -6 degrees, we could say, since that's below 0, we could say 6 below 0. For -5 degrees, if we wanted to write it a different way, we could just write -5, right? Kind of the same difference there. Okay, now we're being asked to put them in order, and we're being asked to put them in order from least to greatest. So if we have our number line, right, we have 0 here, the least would be over here, the greatest would be over here. As you go to the right, you know the numbers get bigger. So if we're looking at, let's see, -8, I'm just going to skim along here and look at all these numbers. I see lots of negatives. The farthest down is going to be -13. -8 would be second. We've got a -6. We've got a -5. And by the way, I'm not actually marking these on the number line. I'm just writing them in the order that they would go. We've got a -4. Now, we're back into 0, which is between positive and negative. We have a +2, and we have 12 degrees. So now these are in order from least to greatest, and to really hit home or point, let's use this to create an inequality statement. So -13 is less than -8, which is less than -6, which is less than -5, which is less than -4, which is less than 0, which is less than 2, which is less than 12. So now we've got our inequality statement, and our explanation says explain why the rational numbers they appropriately represent these temperatures. Why do those make sense? Is because the words below 0 refer to negative numbers. They're located below 0 on a vertical number line. So if we did a number line like this and we had 0, all the negative numbers would be down here. Positive numbers would be up here. If we did our more traditional number line, we have 0. Negative numbers would be before 0 on the line. Positive would be after. Okay, let's look at one more example together. Using absolute value to solve real-world problems. So, question says, the captain of a fishing vessel is standing on the deck at 23 feet above sea level. He holds a rope tied to his fishing net that is below him underwater at a depth of 38 feet. Draw a diagram using a number line, and then use the absolute value to compare the lengths of rope in and out of the water. I'm going to do that, but I want to show you a couple things. So first of all, my brain says I want to draw a picture. So we've got the water level, we've got the boat, we've got our captain here. Maybe he's a pirate. I don't know if I can really add an eye patch there. Or give him a little hat, you know. Okay, kind of looks more like a cowboy, but that's okay. So he holds a rope tied to a fishing net that's below water. He is standing on the deck at 23 feet. So the sea level is here, and that's 0. He's standing at 23 feet. So that is 23 feet right there. If he's holding a rope, and it goes from where he's standing, and it goes all the way down, and here's the net, right? It's all the way down 38 feet to the depth of 38 feet. If something is 38 feet deep, that means we're at negative 38, right? So this, from the water level to where the net is negative 38. It's 38 feet deep. So let's look at the absolute value of these two numbers. The absolute value of 23 is 23, right? It's 23 away from 0 on the number line. The absolute value of negative 38 would still be 38, right? Here's negative 38, and it would be 38 feet away from 0 or sea level, so that's 38 feet. So if we take 38 feet and subtract 23, we're going to end up with 15 feet. And so when it says compare the length in and out of the water, the rope length that is underwater is 15 feet longer than the rope length above water. Okay, that's just my visual representation. Now let's actually use a number line, and I'm going to show you how I'm going to do that. Essentially, we're looking at the same thing, but I'm going to use a vertical number line because, again, he's above sea level. So if we say here's 0, we'll go 10, 20, 30, and then we'll go negative 10, negative 20, negative 30, negative 40. There we can go positive 40, keep it even. He is, we'll do our little boat guy here. Here's our boat guy, boat captain. He is at, oh, that's probably too close to the middle. It's hard to draw with this. He's at 23 feet, right? And so we're looking from 23 feet all the way down to negative 38. So I can look and see that this space from 23 to 0 is 23 feet above water. This would, at 0, is where the water line would be, right? If I go from 0 to negative 38, that is 38 feet below the water level, right? So I know that the rope that's underwater is longer than the rope that's above water. And by how much? Well, 38 feet minus 23, as we've already done. It's 15 feet longer underneath the water level. Okay, we are about out of time on this video. We're going to look at some more examples of this and kind of look at how we can use grids and some other things, number lines, etc., to solve these kind of real-world problems. And we'll talk more about this in class. Thanks for watching.